If you look in enough places, eventually you'll find something profoundly strange. That's been a reliable rule of thumb through the history of science, and last year it proved dramatically true again for astronomer Tabitha Boyajian. While digging through data from NASA's Kepler Space Telescope, which has been monitoring 150,000 stars for signs of orbiting planets, she realized that one of these things is not like the others. A single star in that set, formerly catalogued as Kik 8,462,852 but informally known as Tabby's star, flickers in an inexplicable way, unlike the shadows produced by planets, unlike any known type of stellar pulsation, simply unlike anything seen before. Tabby's star is so unusual that a few scientists, including Boyajian's colleague Jason Wright, raised the possibility that its flickering is not natural but is due to the presence of an enormous artificial construct. That speculation quickly lent Kik 8,462,852 another nickname, the alien Megastructure star, and prompted a flood of breathless news stories. It even got a shout-out on Saturday Night Live. Boyajian's subsequent TED lecture drew even more attention to her star. Update: a week after I posted this interview, Tabby's star got weirder still. A new study shows that it has been inexplicably getting dimmer over the past 3 years. Now Boyajian, who recently joined the faculty of Louisiana State University, faces the daunting task of sorting through a wide range of potential explanations, from mundane to bizarre. You will probably not be surprised to hear that she's not a big fan of the space alien theory, but even the more sober scientific ideas are plenty exotic. I spoke with Boyajian about how she intends to solve her mystery and about the surprising ways that institutional science is stacked against exploratory research that is not guaranteed to lead to clear answers. When did you realize you were dealing with something profoundly strange? There are all kinds of glitches that can come up in the data, and you don't want to spend time on something that's just a glitch. It's one of those things that doesn't excite you right away. To be honest, it was the Planet Hunters, a volunteer citizen science group, who found this. When they pointed it to me, I was like, the data's bad, I don't even want to look at it. But they said, we did preliminary tests and it checks out. I wouldn't have given Kik 8,462,852 a second look if it weren't for that. Then there were more checks that I did, that other people in my team did, that a few different folks at NASA did, and the Kepler team verified the data as well. It slowly built up into a love-hate relationship, because everything we learned about the star made it more difficult to understand it. Everything we observed made the star look very, very normal, except for its very, very abnormal changes in brightness. It didn't resemble any other class of stars that showed any kind of variability. It was a gradual learning process, learning about the star itself and checking out different theories. What do you do when you are confronted with something like this, a star that seems to defy all the usual scientific explanations? When you have something that doesn't fall into any category, you start talking to people. That's what I did, bouncing ideas off colleagues and testing out different theories. By the time we decided to write up the paper, we didn't really have any results, and this anomalous behavior in itself doesn't really make an exciting paper. The way that scientists are trained, you get some data, you test out theories, you present it in a scientific paper. Writing up something like this that doesn't have a result, only questions, is very frustrating with that mindset. We spent a lot of time thinking about Kik 8,462,852. The idea was to write up everything we learned, every theory we thought of that could try to explain the star, and just present it like that. Which doesn't make for a very exciting paper, but it is very exciting because this is something brand new. So like I said, love-hate relationship. It's exciting but it's frustrating at the same time. We're looking at a new class of object, for all we know. The tone of the news reports were not conflicted at all. Of course, they were downright giddy, playing up the possibility that we were seeing an alien artifact around a distant star. How did you feel about that response? I would definitely say it's been overwhelming. Even in the very good articles that have been written about the star, the title is often leading. Some people don't do responsible reporting and take it one step further. You know, it is what it is. I didn't expect this level of excitement at all, but in retrospect I should have. I was surprised that you didn't approach NASA or some other big agency to help solve the mystery. Why not? This star needs long-term, continuous monitoring, because there's no way to predict when something's going to happen. It's not periodic. Government facilities don't have the ability to do long-term monitoring. Public observatories are so well scheduled that you can get maybe 3 nights in a row. There's no way to continuously monitor something on a daily basis. You could get government grants to buy time on a private telescope network, but government grants take a long time. If I wrote a proposal now, and if we actually won, we'd get the money maybe by a year from now. Also, government grants are a very competitive process. There's no guarantee of success, especially for a proposal like this. We're looking at one star, high risk, high reward. That's not something that's appealing to the National Science Foundation. What inspired you to launch a Kickstarter campaign? That also surprised me. Over the past few months, ever since October when the star started being in the spotlight, really I've been getting tons of emails from people asking about how they can contribute. We had a Redditor, and people were offering all kinds of services. I know nothing about science, but I can do coding work. They wanted to be involved. Then I gave a TED Talk in February, and afterward I got approached by a lot of people interested in contributing. Kickstarter was actually founded by a TED Fellow. One thing led to another and this project was born. The Kickstarter campaign captures the best of all worlds, because it lets the public still be involved. It continues the theme of outreach science, since that's how the star was discovered. It lets us update the community on how science really works. That's a positive thing you don't get through government grants, which are very private. So what's the plan of attack? How will you figure out what the hell is happening around this star? The plan is to observe the star through a full calendar year at the private Las Cumbres Observatory Global Telescope Network (COGT). We have the funds to cover that, and a little bit more. We're observing now, running off time. COGT has gifted us 200 hours there. At the end of the summer, when the Kickstarter funds get transferred, we'll be able to set up the process through August and probably through December of 2017. We want to see the star's brightness dip again. It's as simple as that. When it dips, how long the dips are, if there are many dips, all of the stuff relevant to any theory that's on the table. Also, we'll be able to get more detailed observations of whatever stuff is passing in front of the star, because we have a system to notify us when it's not at its normal brightness. COGT is set up so we can get a spectrum as soon as the trigger happens, and also more intense observations. If it's not an alien megastructure passing in front of Tabby's star, then what is it and how will you know? From our new observations, we'll be able to tell a lot about the material that's passing in front of the star. If it's some kind of dusty thing, some kind of solid thing. Boyajian's working hypothesis is that the dimming is caused by a huge swarm of comets, set loose perhaps by some cataclysmic event around the star. What's also important is that we will also get a baseline of spectral observations so we can look at if there's any radial velocity shift or if there's any variable emission of the lines, things we'd expect comets to have. If the dimming is caused by a transiting family of comets, that would be something completely new. We've never seen comets go in front of a star. The dust component of comets is what you'd see in the light curve. What you'd see in the spectral observation is the gas component of comets. It would be very exciting. We've never even seen anything like it in our solar system or around another star. We could learn a lot from that. What kind of signal would tell you that a comet swarm is not the answer, that you need to consider something even more exotic? We'll look at the orbital period, as indicated by dimming episodes that repeat. That might lead us to favor one theory over another. Comets move on very elliptical orbits, though, and if you're talking about a whole family of comets, then individual ones may or may not transit again. That complicates things. The more dips we get, the better. If they're deeper than what we've seen before, if they last longer, any of those observations will help us test out which theory is the right one. So far, Tabby's star seems to be unique. How will we find out if there are others like it, or if this star is really one of a kind? We've searched through the Kepler dataset and we haven't seen anything like this star, at any level, but Kepler has only looked a little over 0.2% of the sky. There are more surveys coming out that will look at huge amounts of the sky. Now that we have the amazing properties of this one star, will we be able to set up an eye to find another star like this? Or will the next one look completely different? We just don't know. What we do know is that if we want to find another object similar to this, we're going to need long-time baseline data. Kepler looked for 4 years, and the star was doing fun stuff for only a tiny portion of that time. Well, that raises an unsettling thought. What if you observe for a year and nothing happens? What if, by bad luck, you catch the star when it isn't doing anything interesting? We're definitely starting to work that out. The longer we monitor the star, the better chance we have a chance to catch new details. Maybe we need something set up for the next 10 years. It's going to take more work. The Cogged Observatory is working with us, and if we need to do another Kickstarter, that can happen, even though it's a lot of work. It's a nail-biter. It seems like there should be a way to carry out this kind of purely exploratory research without having to resort to Kickstarter or the like. What do you think? Just to be clear, we have the support of tons of astronomers. Kickstarter doesn't have to be peer-reviewed, but nobody has said, "This is bullshit, you can't do that, you should be doing science." Everybody understands our point of view. The peer review process works really well overall, but it isn't appropriate when the probability of having results at the end of the year is very low. Having a different, government-funded channel for scientists to do higher-risk proposals would definitely allow a lot of other cool science to get done.